Okay, ladies and gentlemen, here we are with number 5 in the 2017 AP. It's a non-calculator question. You can see the setup we have right here. I can already tell this is going to be a DIVA question. Displacement, velocity, acceleration. They're going to ask me for derivatives and integrals, and they're going to ask me to check features of the graph at that point. Remember, the graph is increasing. So they've given us two equations. One is the position of particle P, which is labeled x of P, and one is the velocity of particle Q. So these two equations are for two different particles, so they're giving us different information. So I've written down the two pieces of information that we have. We know that if we're going to want to know information about x of P, I'm going to be taking derivatives. I'm not going to do it, well, I might do it now. V sub P would be the derivative of that. A sub P would be the derivative of the velocity. Over on the other side, they've given us V sub Q, which means acceleration. Q is going to be the derivative of that statement. And the integral of V sub Q is going to be the displacement. I don't know if I'm going to need it, but I'm going to see what they're going to ask me about. Okay, so the first question they asked me is for t between 0 and 8, when is particle P moving to the left? So in order to figure that out, particle P moving to the left, that's going to be velocity. Is it a positive velocity or is it a negative velocity? So in order to solve that, I'm going to need the derivative of the statement that's there, which would be 1 over t squared minus 2t plus 10 times the derivative of the inside of that function, which is 2t minus 2. I'm going to combine that together. And when I combine it, I'm going to factor it. Because factoring when finding where things change over is always easiest. I'm going to go 2 factor t minus 1. I'm going to factor the bottom, and hopefully it factors. I would bet it would. T and T. T and T, I had to factor this one, but it didn't factor. That's okay. We'll write down what it is. And that is t squared minus 2t plus 10. So to figure out when this particle is moving to the left, we got to check the velocity. Well, where would the velocity be 0? The velocity would be 0 at 1. Because I have a 1 there, it makes that value 0. After 1, the velocity is positive. So it's increasing or heading to the right. When it's negative, it's decreasing or heading to the left. That means that the particle is moving to the left between t equals 0 and
got a quick
t...
question for you. Oh, sorry.
No. Equals 1. So that answers our part A. Maybe I'll write it here. Between t equals 0 and t equals 1. Okay, so for time 0 to 8, it says find all times during the interval the two particles are traveling in the same direction. So we already know about the direction for P, because we have a chart of V sub P. Now we're going to make a chart of V sub Q. Well, Q has a velocity of 0 at 3 and a velocity of 0 at 5. So we're going to find the sign, Michael, not the number, Michael, just the sign of the term in the middle there. Let's pick a nice big number to start with. We'll start way at the end over here. Let's put in the number 100. That's going to make everything positive. This is going to be positive. Okay, let's pick a negative number. Big negative number is going to make both of those things negative, and negative times a negative is positive. So, Michael, we now need a number between 3 and 5. Michael said 3.5, so we'll use 4. 4 minus 5 is negative. 4 minus 3 is positive. Those two multiplied together give me a negative velocity. So there's what's going on. So when are they traveling in the same direction? Okay, it looks like the only time they're traveling in the same direction is between 5 and up. Okay, so between 1 and 3, it has positive velocity, so heading in the same direction. And after 5, they both have positive velocity. So that would be the answer. And it doesn't say justification, but these pictures are enough to justify the answer. So it asks us to find the acceleration of particle q at time t equals 2. So the acceleration of q at time 2 equals -4. Is the speed of the particle increasing, decreasing, or neither at time 2? Oh, those tricksters, they know I need the velocity as well to know if it's speeding up or slowing down. VQ equals VQ of 2, I'm going to put 2 into there, is equal to 4 minus 16 plus 15, which equals 3. So I've got a positive velocity, and I've got a negative acceleration. So the velocity is decreasing at t equals 2 and is slowing down. It can be a little confusing sometimes when they say, is the speed of the particle increasing or decreasing? The velocity is decreasing at t equals 2 and is slowing down, but they're asking about speed. Speed is always a relationship between these two things. So the object is slowing down, so the speed is decreasing. A-S-I-N-G. Always have to look at both. Okay, pause that. Okay, so to find the position of the particle q the first time it changed direction, I went back to the other part. I knew the first time that it changed direction was when t equals 3. I don't see it on the screen now, but if you scroll back in the video, you'll see I found that time before. So the total distance it will have traveled, total distance, sorry, its position, x of q, would be equal to the, first of all, where q was at time 0, plus the integral from 0 to 3 of v sub q, which is t squared minus 8t plus 15 dt. So x of q would be equal to, at time 0 it was at 5, plus I've got to integrate that statement, which is 1/3 t to the third minus 4t plus 4t squared plus 15t from 0 to 3. Now, when they ask us to actually integrate something on the so remember, because it's non-calculator, they don't necessarily want you to work the whole thing out. So this would be equal to 5 plus 1/3 3 to the third minus 3 squared plus 15 times 3. You can leave it like that if you want to work it out. It's 5 plus 9 minus 36 plus 45. You can work that out to be a number. Okay, good work on that problem. See you at the next problem.